All right, ladies and gentlemen, back at it again. This is day 3 of the unit. Clearly, I'm out again, so you should be watching this and taking notes. I expect all the notes to be completed. Let's look at the first part of the notes. Okay, on average rate of change. Y'all know how I do it. Words are words. I want you to have them, but I don't focus too much on it. I like to get straight to the math. So at this point, we're pretty much just filling in blanks. So rate of change is a rate that describes how one, get my pen out, quantity changes as another quantity changes. And you guys are used to hearing it as slope. Okay, so positive rate of change, pretty much went over this in the video yesterday, is when the value of x increases, the value of y also increases. It's kind of repetitive at this point. And the graph slants upwards. So if you remember, if I just draw a line going up like that, that would be an example of a positive rate of change. Continuing to negative rate of change, when the x value, or when the value of x increases and the value of y decreases, and the graph slants downward. So again, from left to right, that would be going down. I'm drawing a linear line, but you can have rate of change. You can have a rate of change on other functions like exponential, quadratic, whatever, right? Continuing, zero rate of change is when the value of x increases, the value of y remains constant. So again, like yesterday, that means it is just a flat line, not going up or down. So it's just constantly going flat. And then undefined rate of change is when the value of x remains constant despite the value of y. The graph would be vertical, or also known as just straight up and down. So it'd be a vertical line that would be parallel to the y axis. So that would be a line just going straight up and down. That would be undefined. I'll show you guys a YouTube video on that when we get back. And I'm sure I think it's called Slope Dude or something like that. I don't know. But we'll find it and I'll play it. I'm pretty sure you guys have seen that before. All right, moving along. Linear functions have a constant rate of change, meaning values increase or decrease at the same rate over a period of time. And so examples of those are every one that I drew here except for the undefined. So that one, that one, that one, no turns, just a flat straight line. Okay, let's go. Trying to make a quicker video for you guys today. All right, so going down, looking at the formula for average rate of change. You guys have seen this before in foundations. So m, remember that slope. Let's write the slope intercept formula. So y is equal to mx plus b, with m being slope and then b being your y-intercept or your starting point. And so to remember that, that's y2 minus y1 over x2 minus x1. That's how you get to m. Okay, that is how you find your slope. So, but when you're given an entire function, then you would use this to do it. It's basically the same thing. It's going to look like a lot. It will look like a lot, but with practice, it should be pretty easy. So all we're really doing is just plugging in. And so when we look at this one below, number 1, this would be like, let me do a different color ink. Let's go with blue. This would be like x1, and this would be like x2. Okay, and so all this part is saying right here that you take the function with x2 plugged in, so this is x2, plug that into there, and you put it in this slot, minus by function of x1, there's x1, take that and just plug that 2 in, and then put it over or divided by the numbers themselves. So that's x2 minus x1. So let's fill that in and see what it looks like. So you got, again, this will look like a lot. So we have, I'll even do it like this. Remember, I always tell you guys, start with writing your parentheses. Minus the same thing. 2 parentheses for x squared minus 3. So the first one, it says to plug in x2. There's x2, so we'll go down. We'll plug in the 4. Second one says plug in x1. That's x1, so we'll plug in x1, which is 2. Now that's all on the top of the fraction. Then it says just put x2 minus x1 on the bottom. So x2 minus x1. And so if we look into what the top turns into, the top ends up turning into, and really you could punch this entire thing in the calculator. But if we did just this section by itself, that would turn into a 29, and the other one would turn into a 5, and so that would be minus 5. Then obviously below 4 minus 2 would be equal to 2. So we do the math on the top, that would be 24 over 2, which would be equal to 12. And so the rate of change between 2 and 4 on that function would be equal to 12. Seems like a lot, but it's really not. Seems like a lot, but it's really not. Again, going on to number 2. We do the exact same thing. So let's set it up. We want to know the rate of change between -1 and 3. -1 and 3. This is a linear function. Let me kind of draw what that looks like above. So here is your x and y axis. We know that this is going to be a negative slope, so the line's going to be going down. And so let's just kind of just throw a line on there. I'm going to erase this in a second. So say the line looked like that. Then my last color, -1 would be, let's say right there, and 3 would be about right here. Now I'm going to box that in. It wants to know how fast this section in here is going down. That's what we're doing. From -1 to 3, what's the rate or the slope for this area of the line right there? That is all we are doing. So let's go back. We're going to fill it in again, but again, replace your x with parentheses. So what do we got? -4. I'm going to put parentheses there, plus 10. Close that in. Minus -4, parentheses. Plus 10. I'm sitting here thinking, guys, this was a quadratic over here. I want to say I was referring to this as linear. Maybe I wasn't, but I have a headache right now, so I'm kind of second guessing myself. But this is not a linear. If I said that a second ago, because this is squared, that means it's quadratic. Okay. Anyways, going back to number 2. All the math is still the same though. So regardless to what I was referring to it as, all this works out. The rate of change is 12. Again, going back to number 2. So now I know I want to plug in right here. I want to plug in x2. That 3 goes with that. And then on the other one, I want to plug in x1. That's all over x2 minus x1. So we just put the exact same thing down here. So 3 minus a negative 1, guys, which we know that that's really like a plus 1. So that's gonna end up turning into a 4. But put it in your calculator if you don't know that. So the top turns into a negative 2 minus 14 over a 4. Then that turns into a negative 16. Just do all this math in your calculator. 4 is equal to negative 4. So we know our rate of change is equal to negative 4. It's really not that hard. It's really not that hard. So moving along though, number 3, let's look at that. There's a part A and there's a part B. It's wanting us to find the rate of change from 1 to 2. This time they're giving us the information in a table. So here's the days. It's looking for days 1 and 2. So there's day 1, there's day 2, and here's the output that goes with it, a 30 and a 19. So we label our x2, and this is our x1, which means this is our y2, and this is our y1. So now, really, we just plug it into the formula for slope. And so we're looking at our y2, which is 30, minus our y1, which is 19, over our x2, that's 2, minus 1. That turns into 11 on the top, over 1, and that turns into an 11. So rate of change between days 1 and 2 is 11. Let's look at part B. So now it's saying it wants to know the difference of the rate of change between day 2 and day 5. So now let's use a different color. Day 5 would now be our x2. And then the first x, because we're doing it in order, 2 comes before 5. So that's x1. You can't have, let's make sure we make this clear. If you have x2 there, well, this can't be anything but y2. You can't have x2 and y1. Some of you guys will make that mistake. But if this is x2, this must be y2, the output that goes with it. That's x1, so that must be y1. So with our green ink here, if that's x1, that must be y1, and this must be y2. Now we're simply just plugging in, guys. Green ink, we have 121 minus 30 over 5 minus 2. That top equals out to 90. What is that? 91 over 3. And then if you put that in your calculator, that will not simplify. I'm going to give you a decimal, so we'll just leave it as a fraction. So rate of change is equal to 91 over 3. That's it. that is it. I guess one thing you can take out of that is it's the same table, but the rate of change up here between 1 and 2 was 11, and the rate of change between 2 and 5 was 91 over 3. That's not 11, so it's not a constant rate of change, which means it cannot be linear. It's something else. Okay, I guess that's all I'll talk about on that for now. But if it's not a constant rate of change, it's not linear. Let's look at number 4. In 2008, about 66 million U.S. households had both landline phones and cell phones. Find the rate of change from 2008 to 2011. Well, it's pretty easy. We'll just mark our X1 and our X2, which is X1. This is X2, because it's from 2008 to 2011, which means we then mark our Y1, Y2. Then we just get to doing the math, plugging into the formula. So 51 minus 66 over 2011 minus 2008. On top, that turns into a negative 15. There's a 3 on the bottom. Do the math on that. Punch it in your calculator. That is equal to a negative 5. So the rate of change is equal to negative 5. So the next question it's asking you is, what does that mean? So let's look at our chart. We kind of didn't do that to begin with. So in 2008, 66 million homes had both a cell phone and a landline. As we can see, that started to go down, and this is in millions. So 66 millions. 1 year later, it was 61. Then it went down to 56. Then it went down to 51. So what that means is, on average, things messing up here. On average, 5 million less homes had both, let's just say, types to limit the writing, per year. So on average, households that had both a cell phone and a landline went down by about 5 million homes per year. Let's keep it rocking. Why is my page not turning? Is that all about? Oh, here we go. All right, number 5. It's saying this is going to be a little bit harder for you to understand. It shouldn't be, because all this is saying is find the average rate of change from 0 to 1. So let's kind of find 0 on here. So let's use green. So we're using the x-axis. So this is 0. So we're saying I'll kind of box it in right there. Then where's 1? This is 1. Go down. Oops. It's 1. So really what we're saying is, as we go down, we'll mark it where we touch the line. So there's a point there, and there's a point there. So from 0 to 1, what's my rate of change? Well, first, is it increasing or decreasing? If I'm standing here and I start to walk right, I'd be going down. So we know the rate of change should be negative. And then you'd find it the same way you would find it on a linear equation. Go to your first point and you go count down. 1, 2, 3 over 1. So that would be a negative 3 over 1, which is equal to negative 3. So, rate of change for that section of the quadratic is equal to negative 3. Anyhow, moving along. So now this is saying, well, what is it from 4 to 5? And so we'll use red lines. We go over to 4, so there's 1, 2, 3, 4. So there's a point right there where it touches. And here's 5, which the point is right there where it touches. So in that section right there, it wants to know what the rate of change is. Well, from left to right, if I'm standing here, if I start walking right, that's going to be going up. So I count the slope. 1, 2, 3, 4, 5 over 1. So that slope would be 5 over 1, which is equal to 5. So the rate of change for that section would be equal to 5. Okay? So notice the difference between sections. Right here, it's going down. Over here, it's going up, and they're both going at different rates. So different types of functions like quadratics don't always have the same rate of change, whereas number 6, if you look over here, this one does. So at this time, is you can pause it, and you can try number 6 right there. You're doing the exact same thing I just did on number 5. You can check your answers with the key. All right, because I'm not going to go over number 6 right now. I'm only going to go over a couple more, and then I can go over this a little bit more when I get back. All right, number 7, same exact thing. It's saying find the rate of change of Pete's height from 3 to 5 years. So 3 would be x1. This would be x2, which means this is y1. This is y2. We're doing the formula the exact same way. So 45 minus 37, y2 minus y1 over 5 minus 3. That turns into 8 over 2, which is equal to 4, which means rate of change is equal to 4. We're just plugging and playing, guys. Take the formula, plug it on in. It's no difference. Moving along. Okay, number 8. There's no difference between number 8 and the very first ones that we did. It's asking you to do the exact same thing, so I'm not going to go over that. Go back and do it exactly how we did this. Okay, number 9. I guess I'll do that one, which is it's the exact same thing. It's the exact same thing, guys. No, actually, I'm not going to do it. I'm not going to do it because you can do it just like this one. It's just one extra term. So you just plug in for x just like you would on this and the first two. Now, number 10, and I expect y'all to do that. Do all the notes, check it with the key. Do all the notes, check it with the key. I'm not playing no games with that. Number 10. All right, let's look at it.
All right, so number 10, you and a friend are trying to decide which theater to go to on a Friday night. NCG charges $7 for the movie ticket and $3 per food item. Regal's prices are represented by the table to the right over here. So it says write an equation for both of them, and then we want to compare the two of them. All right, so first we're looking at NCG. I always say look for the per. Okay, so 3 per, or 3 a day, or 3 each time, something like that. Something's happening on the per. So when you find that, that is going to represent what you put next to the X. Next to the X. That rhymes. Ha ha ha. That was a little corny teacher joke right there. All right, anyways. So we would have 3 x. And then the other thing would obviously be your constant. $7 is something that you're going to be charged regardless of anything else. So plus 7. Okay, so f of x is equal to 3x plus 7. Now let's direct our attention to Regal. Regal is represented by this. So first, we want to know what the slope is. Right here, we knew it was 3 because it's 3 per. Here, we got to get it figured out. So, if we look at this, I mean, sometimes you can just look at something and see this is going up by ones. And so, we really could look at this and see what the change is each time. That's going from 4 to 8 to 12 to 16 to 20. We can see that the slope is going up by 4. But if we couldn't see that, we would say, all right, well, this is x1, this is x2, which would mean this is y2, this is y1, and we could start doing some math, right? We could say 16, y2 minus y1 is 16 minus 12 over 3 minus 2. That would be 4 over 1. Right, which is the same thing as 4. So we know our slope is 4. So 4x. But in order to figure out what our constant is, well, the constant is your starting point or your y-intercept. We just mentioned this, or we just talked about this the other day when I was in class. Your y-intercept is always where x is 0, and your x-intercept is always where excuse me, your y is 0. So here in this table, it makes it easy for us. We can see that x is 0 right here, which means this is our y-intercept. So we can put that at the end there. That is a positive 4. All right, we're going down to the little table down here now. So let's fill out the info. Got our y-intercept. That would be 0, comma 7. And then we got to figure out what f of 4 is. How do we figure that out? Well, we can just do the math. 3 parentheses for x, and then 7, and we plug in a 4. 3 times 4, that's 12, plus 7, that would be equal to 19. So f of 4 is 19. All right, so then rate of change. Well, our rate of change is our slope. So in order to get this, we'll go right there, and we see that our rate of change is equal to 3. Excuse me. So looking at Regal, do that. Looking at Regal now, our y-intercept, we just said what that was. Y'all should know. Put it in an ordered pair. That is 0, because x should be 0 on a y-intercept, comma 4. And then g of 4, we plug in. So 4, parentheses where the x was, plus 4, and then it wants us to plug in a 4, so we're comparing the two. This is 16, bring down the plus 4, that's equal to 20. G of 4 is 20. And then the rate of change, it's right here in your face, which is 4. So now the center of this is wanting us to compare it. Is this stuff less than, greater than, or equal to this stuff over here? So we're looking at the y-intercept. Which one's bigger, a 7 or a 4? 7 is, so boom, that one's bigger. Then you got a 19 and a 20. Which one's bigger? The 20 is bigger. And then a 3 and a 4. Which one's bigger? The 4 is bigger. so none of them are equal. Alright, I am sitting in the car right now, busting this out for you, and I'm about to run into another speaker to go listen to them do their thing. So y'all just listen to me do my thing. Now y'all do your thing and do the work that I've provided for you. No bad reports. I will be back later.